Hey guys, this is Payne. I have a cold. Ignore my voice. Well, don't ignore what I'm saying, but sorry about my nasally. Today we're going to be looking at 1D.2. Our mastery learning objective is I can solve exponential equations by rewriting the equation using the same base. Okay? So I'm still solving, right? So I should get something like x equals, and I'm going to use the same bases. Okay, we talked a lot when like multiplying and all that with the same base. Right, remember the base was being raised to the exponent. So let's look at our steps. Step 1, get the base and the exponent alone on one side of the equation. Okay, so base and exponent alone on one side of the equation. Step 2, rewrite the equation with the same bases on both sides. Use your powers cheat sheet. Alright, so what I'm going to have you do right now is pause this video, raise your hand, and ask your teacher for the powers cheat sheet. Do that now. Alright, hopefully you all got your powers cheat sheet. You will need it for this activity, or for these. I will be referring back to it several times in the video, okay? Step 3, set exponents equal to each other. Exponents equal. And then step 4, solve for the variable. Okay? So let's look at an example. Step 1, get the base and the exponent alone. Here's my base with my exponent. Look, it is alone. There's nothing else on that side of the equation. So that step is done for us. Okay. Step 2, use your powers cheat sheet to get the same base on both sides. So if I look at my powers cheat sheet, sorry, I have a whole bunch of things up, which looks like this. What I'm going to be doing is I want to find both numbers that are on either side of my equation in one of these boxes. Okay, so you have 6 boxes. You need to find both of them in one box, and that's the base you want to use. So if you look, I'm looking for 4 and 8. Okay. Well, if you look here, looking at all these boxes, I have a 4 here and an 8 here. That means 2 squared and 2 cubed, right? They both have a base of 2. So I'm going to rewrite these 4 as 2 squared. I still need the x next to it. I'm going to rewrite the 8 as 2 cubed. Okay, so this is 2 to the 2x equals 2 to the third. And here we wrote that 8 as 2 to the third. Alright, set the exponents equal to each other. Exponent, exponent. 2x equals 3. That's my third step. Step 4, solve for the variable. Remember, this is multiplication, doing the opposite. I'm going to divide by 2. X equals 3 divided by 2 is simply 3 halves. Okay. Let's check our answer. Remember, to check our answer, we simply take our original problem, but instead of x, we just put parentheses. And in that parentheses, I'm going to get what I got. Here, I'm going to put what I got. 4 to the 3 halves. In my calculator, I can write 4. Remember, this is your exponent button. 3 divided by 2. I get 8. Oh, that does look like it works out. I get 8 equals 8. Okay? So my answer here is x equals 3 halves. Example 5. Same thing. First, get your exponent, your base and your exponent by itself. Base, exponent. Look, again, they are already alone. I don't have to do anything for that step. So for you, the exponent plus 2 plus 2 equals 81. This exponent is wrong. It has multiple pieces to it. But that x plus over 2 plus 2 is all still the same exponent. Okay, so I don't have to move anything. Step 2. Right? Get them to the same base using that powers cheat sheet. I'm looking for 3 and 81 in the same box. Wow. If I look over all of these, I have a 3 and an 81. 3 to the 1, 3 to the 4. Okay. Well, 3 to the 1, I don't like to write the 1, remember? So it's still just 3 to the x over 2 plus 2 equals 3 to the 4th. We don't ever write an exponent of 1. It's just understood to be there. Okay? Set your exponents equal to each other. I have an exponent of x over 2 plus 2 and an exponent of 4. The next thing I have to do is just solve. Remember, we always deal with the addition and subtraction first. I'm going to subtract 2, doing the opposite. X over 2 equals 4 minus 2 is 2. The next thing I'm going to do is, right, this is division. The opposite of division is multiplication. X equals 2 times 2 is 4. Okay? X equals 4. Then, checking my answer, I rewrite this whole thing. And I just put 4 into the parentheses. So 3 to the 4 over 2 plus 2. 3 to the 4 divided by 2 plus 2. I can write it exactly like that. And I do get 81. And that does check out. We are good there. More examples on the next page. Okay. I have 2 to the 2x plus 2 equals 2 to the 3x. This one's a little bit different. I have a base with an exponent on this side and a base with an exponent on this side. This is your one case where it is okay, right? If they're both alone, right, they don't have anything extra, it's fine. I don't have to do anything extra with this problem. I don't have to move them over or anything. Okay? Step 2. Well, step 2 is also nice. This has a base of 2. This has a base of 2. And I'm going to need to use my powers cheat sheet. They already have the same base. Step 3. Set your exponents equal to each other. 2x plus 2 equals 3x. Step 4. Solve for x. Remember, I have 2 variables here. I want them all on the left. So I'm going to subtract 3x from both sides. 2x minus 3x. 2 minus 3 is negative 1x. Plus 2 equals 3x minus 3x is 0. Now I need to move my constant to the right. Minus 2 minus 2. I have negative 1x equals negative 2. And finally divide by negative 1. X equals negative 2 divided by negative 1 is positive 2. Now again, I want to check my answer. So I'm going to put 2 to the 2 with the parentheses instead of the x plus 2 equals 2 to the 3 with parentheses. In that parentheses, I'm going to put this 2. Now, I'm just going to type the left side into my calculator first. Okay? 2 to the 2 times 2 plus 2. Lots of 2. 2 to the 2 parentheses 2 plus 2. Exactly how it looks. I get 64. Now I'm going to type this side in. 2 to the 3 times 2. Again, I get 64. Okay, so you should be typing it in exactly how it looks. 64 and 64 are the same. Check. Looks like our answer is x equals 2. All right, looking at example 7, last example. Our first step is to get our base and our exponent by themselves. Oh no, in this problem I have a +1, right? So this is our one example where we do have something with it. So that's really 3 to the 2x minus 1. I have to subtract that 1 equals 28 minus 1 is 27. Step 2, write them with the same base. I have a 3 and a 27. Looking at my powers cheat sheet, I have 3 and 27 in the same box. 3 to the first, 3 to the third. Okay? So again, I don't ever write that 1 exponent, so 3, it just stays the 2x minus 1. 27 becomes 3 to the third. Step 2, set them equal. 2x minus 1 equals 3. Step 4, solve. Add 1 to both sides. 2x equals 3 plus 1 is 4. 2 times x, I'm going to divide both sides by 2. 4 divided by 2 is 2. So for this problem, we get x equals 2. Now I want to check my work. 3 to the 2 parentheses plus 1 equals 28. What am I going to put in that parentheses? That 2. Right? So again, this goes in our calculator. 3 parentheses, or 2 this 2 parentheses 2 minus 1. And then remember, for this next part, I didn't write this right. Sorry, guys. It should look exactly like this. Minus 1 plus 1. I just merged those things. So 3 to the 2 times 2 minus 1, and then plus 1. Right? This plus 1 is not in the exponent. So when I'm looking at my calculator, I have to hit to the right to make sure it's not in my exponent. Okay? So make sure there's a difference between those two things. Okay? I do get 28. 28 equals 28. That checks. Okay. Alright guys, that's it for this video. Go ahead and work on 1D.2. In the next activity, be careful. There are lots of problems. You only have to choose 6 of them to do. Don't go over. Don't do too much work. Alright? See you guys next time.